Yes, in order to answer this question, I think that we have to make a distinction between three different areas of applications. In particular, the major hazardous plants, that is the first category, the traditional installations where the risks are not so big, and the transportation. The first two are related to the industry. In particular, when we refer to major accident installation in industry, we have a legislation that is performance-based, goal-based, and that is the Seveso Directive that is valid in all the Europe and is applicable, must be applied in all the member states. In this sense, we could say that more or less all the member states, all the country approaches the safety of major hazard installation in the same way. Obviously, when we design a plant in order to produce a storage hydrogen, except in case we have a very large amount of hydrogen stored in the plant, that is a quantity that is higher than 5 tons of hydrogen, that is 50,000 cubic meters, so it's a very big amount, except in this case, our facility is not inserted in the Seveso directives. So the Seveso directive must not be applied. But sometimes we apply these hydrogen technologies in existing plants. For instance, refineries, where we have other dangerous products, and putting all together, we reach the level to enter in the validity of the Seveso directive. But as I mentioned before, in this case, the regulation is very good, is performance-based. This means that the manager has to demonstrate by a risk analysis that the technology is safe, that all the design, operation, and maintenance action have been set in order to guarantee a good level of safety for the technology. For the other industrial installation where the risk is lower, and most of the technologies of hydrogen are involved in this second category, because the amount of hydrogen is not so big, but in any case, we have to manage the risk of this kind of flammable gas. In this sense, for instance, in Italy, we have a prescriptive legislation that is a national legislation where the reference authority is the fire brigade. In this case, when we design a new technology, we have to follow the prescriptive legislation, that is a set of rules that must be implemented in order to guarantee that the plant can be built and then operated according to the authorization delivered by the fire brigade. Today we are moving also in the fire prevention in Italy in the direction of a performance-based legislation. So the fire protection, fire prevention regulation that was completely prescriptive in the past now accept the risk approach as an alternative to the adoption of the precise rules, and this gives new opportunities for the design of hydrogen installation. For this kind of installation, industrial installation, the situation is different in the different member states of Europe. For instance, in Germany, the fire prevention authorization are delivered by the TÜV, that are a private company that make investigation on the design of the system, on the operation applied for the system, and deliver their certification that the plant is safe enough. So the approach is completely different. For what concerns transportation, at the moment, worldwide, we have a regulation that is, for the moment, prescriptive. So we have no rules giving the possibility to approach the problem from a performance-based or goal-based point of view. And this could be a problem because the prescriptive legislation, the list of rules that give us the indication how to design, how to operate, and so on, are good when the technology is frozen. But today we are trying to introduce new technology, innovation. In this case, if we can authorize a system that must be traditional, the innovation is frozen. So we need, not only in industry, but also in transportation, a new culture of the regulation that gives us the possibility to suggest, to implement new technologies, and obtain the authorization to the construction, the authorization to the operation by a different approach that is goal-based. We have to reach a safety goal. The designer, the proposer of the technology must be able to produce a risk analysis to demonstrate that the safety goal for the new technology is reached and the safety is comparable with traditional technology. On the opposite, the authorities must be able to interpret this kind of risk analysis in order to decide if the design, the operation, and the maintenance of the system are well defined or not. So, in order to facilitate the innovation, in particular in this moment where we are trying to make an important energy transition, ecological transition, we must change our approach to regulation also in order to give the possibility to invent new strategies, new applications, new technologies. But on the other side, we have to prepare people to change the culture of the people in order to give to the technicians the possibility to manage friendly risk analysis. That is a tool that is important in this particular moment.
Buongiorno, sono l'ingegnere Alessandra Di Castro di IT Hydrogen. Oggi ci troviamo presso il nostro centro di Bolzano, che attualmente è l'unico centro di produzione di idrogeno verde attivo in Italia con annessa stazione di rifornimento. L'idea del centro nasce all'inizio degli anni 2000 per sviluppare le infrastrutture sostenibili della mobilità locale. L'impianto di produzione è entrato in esercizio nel 2013 e la stazione di rifornimento nel 2014. La stazione di rifornimento è stata progettata per alimentare qualsiasi tipo di mezzo ad idrogeno, quindi sia automobili che veicoli commerciali leggeri e pesanti. Abbiamo infatti 3 colonnine di rifornimento, una a 700 bar per rifornire le automobili e una a 350 bar per rifornire i mezzi più pesanti. L'idrogeno che eroghiamo è prodotto dal nostro impianto di produzione, che ha una capacità produttiva di 360 kg al giorno circa, e finora la stazione di rifornimento ha erogato più di 170.000 kg di idrogeno. L'impianto di produzione produce idrogeno tramite idrolisi alcalina, quindi partendo da acqua e da energia elettrica rinnovabile, nel nostro caso energia idroelettrica. L'idrogeno prodotto viene poi purificato, compresso e stoccato per poi essere utilizzato sia dalla stazione di rifornimento che per poter caricare delle bombole su dei caribombolai. Allora, nel 2014, quando abbiamo messo in funzione la nostra stazione di rifornimento, effettivamente non c'era ancora una normativa che andasse a legiferare come progettarla e come esercirla. Abbiamo quindi lavorato a stretto contatto con le autorità, in particolare per quanto riguarda il tema antincendio, per andare a progettare ed esercire la stazione di rifornimento nella maniera più sicura. Siamo stati dei veri e propri pionieri in questo settore e ancora oggi infatti collaboriamo con gli enti che sviluppano le normative sia a livello locale, a livello nazionale ma anche a livello europeo per cercare di renderle sempre più efficaci e operative.